ASN Filter Designer provides Arm Cortex-M developers with an easy-to-use, powerful signal processing platform for developing real-time dataset cleaning algorithms and feature extraction algorithms for their AI IoT applications. Typical examples include building applications that clean and extract Q, R, and S features from ECG biomedical data for machine learning algorithms in telemedicine applications, cleaning IoT sensor data such as data from accelerometers, gas and temperature sensors for Industry 4.0 applications, as well as enhancing other time series data. Many customers report are saving by as much as 75% in R&D costs as the platform expedites the process of dataset analysis and designing suitable cleaning and feature extraction algorithms. Let's now have a look at the UI. As seen, the intuitive real-time user interface allows developers to graphically experiment with their design requirements by just using the mouse, meaning that a suitable digital filter can be designed and customized within minutes. The graphical designer is strengthened by a comprehensive scripting language, providing developers with over 82 scientific functions and detailed examples, allowing for the design and customization of specialist filters with advanced specifications using easy-to-understand symbolic mathematical expressions. A real-time simulation environment is also provided and includes comprehensive data analysis functionality, allowing for the validation of the design filter using simulated or imported datasets. As seen here, importing an ECG dataset can be achieved by simply dragging and dropping the comma-separated file or text file directly onto the canvas. The import wizard will then delimitate the data, and after saving, the tool gives you the option to automatically import the data file into the signal analyzer for playback. Using the data analysis UI options for frequency measurement, the built-in algorithms can be used for extracting biomedical features from the dataset. As seen here, the heartbeat or RR duration from a cleaned ECG dataset can be easily analyzed in real time using the data analysis options. When ready to deploy to a Cortex-M device, the tool provides developers with a simple-to-use one-click code deployment wizard. Upon opening the wizard, the current design will be automatically analyzed and the tool configured for deployment to the Arm CMSys DSP framework. The developer now only needs to simply specify their desired quantization requirement and leave the tool to do the rest. The code generated is compatible on all Arm Cortex-M devices from the M0 all the way up to the M33, and by checking on the Helium option, code for the new M55 and M85 AI code processors can also be generated. For developers looking for a more detailed architectural description, the platform's CMSys DSP code generator is discussed in detail in Arm's latest architecture book on the M23 and M33 cores. The book provides loads of tips and valuable insights into implementing real-time filtering applications on Arm Cortex-M cores using RTOS and the SIMD instruction set. Certainly worth the read. In order to expedite development, our team have developed a number of tutorials that are available on our website on the Developer Help portal. We also provide 2 detailed ARM Microvision project examples. These projects are available in a Microvision software pack, which may be downloaded from Keel's website for direct use in your application. The generated code can now be used directly as is in an existing ARM Microvision or Keel Studio project, allowing developers to focus on their application rather than details of the implementation. For more advanced designs that make use of the platform's complete signal processing cascade that fall outside of the scope of the CMSys DSP library, we provide developers with a variety of deployment frameworks, including C#, MATLAB, Python, as well as an ANSI C deployment framework, where the latter can be used directly on all Arm Cortex-M devices. Our close collaboration with Arm's architecture team means that our C SDK implementation on all Arm Cortex-M devices is extremely efficient. As seen here when comparing our C SDK, shown in blue, with Arm's CMSys library, Notice that our C SDK is very comparable to ARM's optimized library, where the lower the amplitude, the higher the performance. A detailed application note is available for developers wishing to know more, and the SDK source code is open source, which overcomes any difficulties with project integration and allows you to choose a level of optimization that suits your application. The generated code may be run in Microvision or any other IDE, such as STCube IDE for STM32 developers. Although notice that the C code generation wizard produces a project file for the free open source CodeBlocks IDE, allowing for developers even on a shoestring budget to get their application up and running without any hassle. It really is as easy as it looks. Please visit the ASN Filter Designer project homepage and see for yourself how to get your Arm Cortex-M AI IoT signal processing application up and running within minutes.